So for example 1 here, we are going to look at example 1, and this would be on your non-calculator part of your exam, even though it doesn't appear right away that you would notice that it would be non-calculator. Okay, we're going to solve the equation. First, it says from negative 360 to 0, and then we're going to write our general solution. Now, whether you're solving it over an interesting domain like negative 360 to 0 is not your normal domain, or whether you're writing the general solution, I like to start by solving it between 0 and 360 or 0 and 2 pi, because that's sort of what you get used to. So if you find out what are all the solutions from 0 to 360 degrees, once you find those solutions, then you can look back at your domain and then decide, oh, my domain is different, so I need to find coterminal angles with these ones and write them out. So if we're solving for this one, first of all, you've got sine x's on both sides, you've got numbers on both sides. We can put some like terms together. Subtract 5 on both sides. That'll give me 2. If I subtract 2 sine x on both sides, I'll get 2 equals 2 sine x. Divide both sides by 2. And you get sine x equal to 1. Anytime that you get a question with sine and cos that's on your non-calculator part of your test or exam, it's going to mean either A, it's something on your pie plate, or B, you get something that has no solution. So we have to decide sine x equals 1, is that on our pie plate or is that something that has no solution? Is the y coordinate ever equal to 1? Yes. What's the angle? Pi over 2, and since this one's dealing in degrees, 90 degrees. So chances are you will naturally solve it between 0 and 360 or between 0 and 2 pi right away, because you're just used to looking at your pie plate and solving it that way. Okay? Once you've done that, now we have to say to ourselves, hey, wait a minute, what was the domain that they were asking for? And here, they were asking for negative 360 to 0. So that's from 0 to 360 in the negative direction. So now what would be coterminal with 90 degrees between 0 and negative 360? So our answer is negative 270 degrees. Maybe we have to show that we know that that x equals 90 degrees wasn't part of the answer because it was outside of our domain. It's not bad that we used that for work, but this is going to be our final answer. Now right beside it here, it asked for the general solution as well. And if you go back to 7.1 when we made our notes on the general solution, you'll say, okay, what did we write down? It said solve like normal between 0 and 2 pi, or in this case between 0 and 360. And then step 2 was add 2k pi to each of your answers. That would be if it was in radians. Because we're in degrees, we'd add 360 degrees times k. So that idea stays the same. So we've solved it between 0 and 360. Our only answer was 90 degrees. Then to have all the coterminal angles with 90 degrees, we take 360 degrees and multiply it by k, where k is an integer. So there's part A. For part B, use algebra to determine the general solution of the equation cos 3x equals negative 1 over the set of all real numbers, then list the roots. So we've got general solution again in this question. And do you remember the name that we used when we had a number inside? What kind of question did we call this? a multi-revolution question. So we're going to just write it out again here, part B, right? Remember that we call this a multi-revolution question because if we first try to solve it between 0 and 2 pi, and this question is, if we write out our domain from 0 to 2 pi, 3x's multiply everything by 3 would be between 0 and 6 pi, which is, if you think of your unit circle, 3 times around. So we're going to solve this for going 3 times around. First time around, looking at the answer, -1. Is our x coordinate ever -1 on our pi plate? Yes. At pi. So 3x is our angle. So we can imagine if you had cos theta equals -1, you would write theta equals pi. Now we have cos 3x equals -1, so we write 3x equals pi. But that's only our first time around the circle. That's our only answer the first time around the circle. In the second time around a circle, what answer would we get? Here's our unit circle. We're saying that our answer is right here at pi. That would be once around the circle. In the second time around the circle, what angle would that be? 3 pi. And notice all you have to do to figure that out is figure out a coterminal angle with pi, so you would add 2 pi. The third time around the circle, you would get 5 pi. So now dividing by 3, 3 pi divided by 3 will just be pi. Dividing by 3 solves for x. And just like we've been normally doing, what did I do? I just solved between 0 and 2 pi. Now I'm going to go back and see, what did my question ask for? What was the domain that they wanted? Well, they said, let's find the general solution. So the general solution says, find your answers between 0 and 2 pi. Then take each of your answers and add 2k pi. Because this will write every single coterminal angle with those 3 angles. So this will be our general solution. So that was the first thing that this question asked. The second thing that this question asked is, after solving the general solution, it said, then list the roots from -2 pi to 0. Well, again, it's nice to have my answers from 0 to 2 pi. I can draw a picture of this to visualize where are those 3 answers. One of them is at pi over 3. One of them is at pi. And one of them is at 5 pi over 3. Those are my 3 answers in the positive way around. Now, if I'm thinking from 0 to -2 pi, now I'm thinking, what's this angle in the negative direction? What's this angle in the negative direction? And what's this angle in the negative direction? 2 ways that you can go about this. Maybe once you've drawn the picture and you know where those angles are, you can easily figure them out. Maybe you'll be able to just say, I know that that first one is -pi over 3. The second one would be -pi. And the third one would be negative 5 pi over 3 because it's part of the pi over 3 family, and it's going basically 4 quadrants in the negative direction. So I know that 5 pi over 3 is my angle in quadrant 4, so if I'm going in the negative direction, that would be negative 5 pi over 3. Most of the time when I'm figuring out my negative angles, that's what I do. I think about where they are, and then I can figure out what those angles would be just from the picture. But another thing you could do is you could take each of your answers from 0 to 2 pi, and you could subtract 2 pi from each of them. Because subtracting 2 pi would give you a coterminal angle, and since your first angles were in the first time around, subtracting 2 pi would be in the first negative rotation around the unit circle. Of course, now you'll have to do a little bit of work. In order to subtract fractions, you need a common denominator. So you would think of subtracting 2 pi like subtracting 6 pi over 3. 1 pi over 3 subtract 6 pi over 3, well, that gives you negative 5 pi over 3. Negative pi minus 2 pi, that's just your negative pi. And 5 pi over 3 subtract 6 pi over 3, that will give you negative pi over 3. So now we were able to solve the general solution, which is what they asked for first, and then find a specific solution over the domain that they asked for. But the key thing that I want to point out here is no matter what kind of solution they're asking for, it's usually easiest and helpful to find your answers between 0 and 2 pi or 0 and 360 first. Because you're used to that, you've done your pi plate, you know your values from 0 to 2 pi, and so that's a good starting point. And then once you have those values, then you can find your coterminal ones easily from there. So the questions that are related to this, that we're going to take some time right now and work on, are 4, 8, and 9.